show you how the temperature indicator controllers are configured and what are the inputs and what are the outputs and what are types of outputs and how it is wired and configured. Let's go to the controller. I'll show you a closer look first. You can see this is the controller I'm using. I'm using the Autonix controller, Autonix TK4S controller, TK4S temperature indicator controller. It also shows the indication of the current or the process temperature and also gives the controlled outputs. There are two types of output which I'm getting. One is on-off control and another one is the PID control. These are the two inputs and I'm going to tell you about the outputs. First thing is the RTD input. Next one is the thermocouple input. And these other inputs are available also, which one is the millivolt, 420 milliamps. Those inputs are also available. By now I am using the normal K-type thermocouple. I don't have the RTD, so I am using the normal thermocouple unit. K-type unit which I have connected to the temperature indicator controller, and I am using two types of output. One is normal on or off control and another one is the PID control. Let's go and find out what is the difference between PID and on and off control, and also let's figure what is the types of inputs or the types of RTDs or the types of thermocouples, and let's see. For this time we are going to discuss about how the on and off controls and the PID controls are different. And first we can go to the on-off control, and you can see this is the on-off control graph, and you can see when the process variable, this is the process variable which is the PV process variable, that could be temperature. In our condition it is temperature, and when the process variable is increasing up to the set point, when it is gaining the set point, and the output is on during the process. That is only when the set point is achieved that output turns on. That's it. That's the on and off control. And next one comes with the PID control. Okay, there we go to the PID graph. We can see this is the process variable. This fluctuating output is the process variable, and you can see the overshot here. And you can see this line, the horizontal line is the set point of the controller. If the set point is 100 degrees Celsius, we can set the set point as 100 degrees Celsius. The PID output will be coming like when the heater is on, out is on, and you can see it is attaining the set point and it is not stopping. The heating process is not actually stopping. It is taking an overshot. It is going around 108 degrees Celsius. It's not accurate, but I can show you what is the overshot. And it is attaining the overshot, then it is falling back to the set point, and it is not stopping, it is not again starting, it is falling. The heater output is on after the overshot, and then comes the output is off after the overshot. Then the output is falling, then again taking an overshot. Out is again turning on. That is the process. Out is on, off and on. It is damping and stabilizing inside the set point. That is a PID control. So in the huge temperature that the normal condition, the temperature cannot be set at the preset or precise set point. That can be only stabilized around the temperature range for the high temperature or the highly varying temperature. That's why we are using the PID controls. Okay, in the normal conditions like iron box, we are using the on and off controls for the temperature optimization. That's it. I just connected an output here. This is my output, this LED or this bulb is an output. This is my thermocouple input, which is K-type. And let's power up. And now this is the startup screen, and we can go for the basics now, which is the process variable 28 degrees, and the set point is 35 degrees, which I can go for the basic programming parameters. I can show you. We just press the mode button for a couple of seconds, and that will show the parameter 1. Parameter 1, I'm going to change it to parameter 2, 3, and enter to the parameter 3. I just want to press the mode. Now we have entered the parameter 1, which is the IN space T represent the input, which is the K type input I just selected, and I just want to show you the outputs and the other inputs by pressing the mode, which is the unit is degree Celsius. I can change it to the Fahrenheit or degree Celsius, and again pressing the mode button, you can see the other parameters, like the low set point is the low value, process value is minus 200 degrees Celsius, and high is 1350. And the next comes with heating, and the control output is the PID. I can change the control output. That's the main thing. First I'm going to show you the on off control. By setting the on off control, I just want to go set the mode button. Now it is in the on off control, and I am going to enter again. We are back to the parameter. I just want to exit from the parameters. Just press and hold the mode, and now it is 27 degrees at the process variable. And during the on off control, the output 1 is on. Output 1 I have wired to the LED or the light, and I can show you when the input is attaining the 35 degrees by I'm just giving some heat to the thermocouple, and it will show the input. It is increasing 28, 29, and when it is reaching the output, reaching the 35 degrees, that will stop the output, or that will give the cutoff. That is the on and off control. When it is the process variable reaches the set point, that will cut the output. See, when it is reaching the set point 35, that the output is off because no longer heating action is required now. So when the temperature is falling back to the normal conditions below the 35, that will again trigger the output. That is a normal on and off control. And the next one, we are going to learn the PID control. That will getting a hysteresis or hysteresis of some 1 degree, 1 or 2 degrees, because it is getting output when it is falling back to 33. Okay, when I am increasing again, I can show you when the temperature is again increasing 33 and 34, and there comes to the 35, and it is cut off at the 35th degree Celsius. Now I'm going to show you how to configure the PID. So I just want to press the mode button for a couple of seconds, and we access the parameters. Parameter 3 we are going to configure, mode button, and it is K type. If you want to change the type into K type or J type, we can change by pressing the up and down buttons and set the mode, that you can change the type of input, whether it is 4 to 20 or 0 to 10 volt or any other types of RTD or the normal temperature thermocouples, whatever you can select from the manual. I'll show you on the manual section, and you can go to the mode button, hit the mode button, unit is degree Celsius, and we can go to the control by pressing the mode button. Now here comes with the on off control. I just want to change it to the PID. Now it is on the PID mode, and I just want to hit the mode button. Now we are on the PID mode, and I am exiting, again pressing the mode for 3 seconds, and it is the PID control, and I'm going to show you the PID on and off, type of on and off. I'm just increasing the temperature. It is not even on at the below the 35 degrees. It is actually fetching the values for the calculation for the increment or decrement of the temperature. It's fetching the rate of the increment of the temperature for the on and off occasion. It is off at the 33 degrees Celsius, and that will increasing again, and it is again on and off. It is actually I shown in the graph, which is damping. It is getting overshot, and it is getting damping on and off and on and off. That is the PID type of PID output. The internal calculations are totally internal. We can do whatever we want. We don't have to bother about the calculations. See, it is at 36 degrees Celsius even it is getting the output. That is a PID overshooting. And when the temperature is falling, the rate of the on and off should be reduced. That is the actual PID behavior.